The rest of this chapter, for the most part, will deal with how to prove that two triangles are congruent. And we actually have 5 different ways to prove triangles are congruent that we're going to look at. We're going to look at 2 today, and then 2 next time, and then 1 in that last section. So let's go ahead and jump in. You can see that the first 2 ways are going to be SSS and SAS. So SSS stands for side, side, side. And what this tells us, if we have 2 triangles, so let's draw 2 triangles. We'll call them A, B, C, and D, E, F, because I have no imagination whatsoever. We've got 2 triangles, and each side in one triangle has a corresponding congruent side in the other triangle. Then we know the 2 triangles themselves must be congruent. So if we know that AB is congruent to DE and BC is congruent to EF and AC is congruent to DF, if we know all of that is true, then we know triangle ABC is congruent to triangle DEF. And our reason for that would be by side, side, side. So if we have 3 pairs of congruent sides, that's what we need for side, side, side. And just as a note, let's say you see a figure like this. If we had those sides congruent, when they share a side, you will see this all the time. When they share a side, that side is congruent to itself. So that counts as one of your pairs when they share a side. You will see that over and over and over again. So that's our first method of proving triangles congruent. Side, side, side. Our next one, and we just abbreviate that SSS. Our next one is side, angle, side. And we abbreviate that SAS. Here we've got triangles LMN and PQR. And if we know that we have 2 pairs of sides and what we call the included angle, I'm going to write that over here and we'll come back to it in a minute. Included angle, then that makes our triangles congruent. So if I know that LM and PQ are congruent, and I know that LN and PR are congruent, and then I need what's called the included angle. It's the angle made of the sides that we're looking at. So what is the angle made of side LM and side LN? Well, that is angle L. What is the angle made of PQ and PR? That is angle P. Okay? So an included angle is the angle made by the 2 sides. So if I have 2 pairs of corresponding congruent sides and their included angles are congruent, then we know that triangle LMN is congruent to triangle PQR, and here our reason is by SAS. And it's the included angle, and so that's why the A is between the two S's, because it is included between the S's. Now, does side-side angle work? And the answer is no. Let's say I had, okay, I'm just going to draw all right, so looking at these two figures, neither of them are triangles, but I'm trying to prove a point. Are these bottom two sides congruent? They're both labeled as 5, so yes, they're congruent. Are these two sides congruent? They're both labeled as 3, so yes, they are congruent. Are these two angles congruent? They're both 60 degrees, so yes, they are congruent. So we have two sides and an angle here, but you can tell that this side, while it may touch this over here, this side doesn't look like it will ever connect with that. Side angle does not work. There is never a situation where this is going to work. So just scratch it off your head. Side, 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 side angle, side. So for these 6 problems, we just want to look at these and see if we have enough information to show the triangles are congruent. If we do, we'll give that reason. If we don't, we'll say no, or not enough information. So for A, here we've got these two sides. Now, something should jump out at you immediately when you see this picture and several of these pictures. These share a side. Okay, when they share a side, you mark that side congruent to itself. So here we've got two pairs of congruent sides, and we've got perpendicular boxes there. Now, we don't have anything marked congruent, but are all right angles 90 degrees? They are, so all right angles are congruent. That's actually a theorem. All right angles are congruent. So we know that we have those angles. So if you want to turn that into congruent marks, that's fine. So we've got two sides and an angle. Is that angle included? Is it made up of the red and the blue marks? It is. So that means that this is side, angle, side. For B, this should jump out at you. They share a side. It's congruent to itself. We've got another pair of sides marked. We've got a pair of angles. Now, for the lower triangle here, the angle is included. It's between the two sides that we have. But the other angle is not included. We would need it to be this angle to be included, and it's not. So for this one, all we can say is no. We don't have enough information. They could be congruent, but we do not know. For C, again, they share this side, so we should mark that. It's congruent to itself. And you can see here we have that side, we have the pair with the 2 marks, we have the pair with the 3 marks. So these will be congruent by side, side, side. For D, we've got a pair of sides here, we've got a pair of sides here, but that's all we have. That's not enough information. We always need at least 3 things in order to show they are congruent. And so this one is another one that is no, because we only have 2 things. On E, again, we've got a shared side, mark that. Now, is our angle included right there? It is. Is it included down here? It is. So since we have 2 sides and they're included angles, we know that it is congruent by SAS. And then our last one, again, they share a side. We've got included angles here, so that one is going to be SAS also. Now we're going to do some proofs together that prove two triangles are congruent. So we are given H is the midpoint of GT, and we know HR and IH are congruent. So first thing let's do is write down our given. So H is midpoint of GT, and HR is congruent to IH. Our reason is given. Before we do anything else, let's draw that in the figure. Okay, HR is congruent to IH. So we've got that marked. I put a point at H, but it was just for fun, just to remind myself there's a point there. It's got to be important because we were given it to us. Now, what is a midpoint? What is the definition of a midpoint? Well, midpoint, remember, is a point that splits a line segment into two congruent line segments, which means GH and HT have to be congruent to each other, because that's what a midpoint does. That's its definition. So our reason is definition of midpoint. Now, something else that should jump out at you when you look at this picture is that we've got some vertical angles here. What do you know about vertical angles? Okay, not what they are, but what's a property of them that you know of. And it's that they are congruent. So we know that angle IHG and angle RHT are congruent because they are vertical angles. That's the vertical angle theorem, or you can just write vertical angles are congruent. Now, looking at our picture, do we have enough information to show the two triangles are congruent? We do, because we have two pairs of congruent sides and the included angles. So we can say, that's a horrible triangle. Triangle GHI is congruent to triangle THR. And we just said it's two sides and their included angle. So that would be side angle side. Now for our next proof and the last thing we're doing today, okay, we know we have isosceles triangle ABC with base AB, and we know P is the midpoint of AB. So let's go ahead and write down what we know. Iso triangle ABC with base AB, and P is midpoint of AB. Those are both given to us. So let's take the first part of that. Isosceles triangle ABC with base AB. What's an isosceles triangle? It's a triangle with at least two congruent sides. And we're not told which two sides are congruent, but we are told which side is the base. Now the base is the non-congruent side. So we know that AC and BC have to be congruent, and that's because we have an isosceles triangle. So that's definition of isosceles triangle. Triangle with two sides congruent. Let's mark that in our picture. All right, that's about all we can do with that for right now. We're also told P is the midpoint. Okay, and we just talked about what a midpoint is. So we know that AP is congruent to BP by the definition of a midpoint. And again, we just discussed that. We're not going to discuss it again. So let's mark those two pieces congruent. And then we have something that in pictures, I've already told you today, needs to jump out at you, and that's that these share a side. Now in a proof, we actually have to write that down as a statement, that CP is congruent to CP. It's congruent to itself. And the reason for that is called the reflexive property. Anything is congruent to itself, or you could say anything is equal to itself if you're dealing with equals. So now if we look at these two triangles, we have enough information to show that they are congruent because we have 3 pairs of corresponding congruent sides, which uses side, side, side. So thus far we've covered 2 methods for proving triangles congruent. We've got side, 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 and side, angle, side. So make sure you do your practice work. Get ready for the mastery check. Good luck.